There's a basic arithmetic video on Surds. We're just having a look at a few quick examples. We're asked to express square root of 48 in its simplest surd form. And what we're looking to do is to break up 48 into factors, one of which is a square rootable type number. So the factors of 48, I'm here to tell you that there's 16. We could write that as root 16 times 3. Now, whereas there's a surd rule that says we're allowed to express a product that's having a square root above it as separate square roots. So we could say root 16 times root 3. And of course you can notice that 16 is a square rootable number. 4 4s are 16. So we end up with 4 root 3 there, and that's been simplified nicely. So we look for breaking up any numbers that we want to simplify into two factors, and we're really looking for the square numbers to be the key here. If we can get one of the factors to be 4, 9, 16, 25, the square numbers here, these ones are great to break up into factors, because then they can simplify further, as you saw there with 16. So explore the factors and see if you can get one that works there. 3, if we've got a 3 out the front, that doesn't make too much of a problem here. We're really thinking of things separately. 3 times root 32, we'll just write out a bit more clearly there. And 32 can be broken up into root 16 times 2, and we're allowed to then express that separately as well. 3 times root 16 times root 2. Now when the 16 becomes a 4, the square root of 16 becomes a 4, it can then start talking to the other normal numbers if they appear in the question. So we can do 3 times 4 now. Seeing it went from being a surd to being a normal number, we can then join it in a normal way and say 3 4s are 12. So 12 root 2 there. So a little bit of work, a little bit more work there, but the main thing we did to simplify was to break up 32 into two factors, one of which is square rootable. Remember, the square rootable numbers, the square numbers are 4, 9, 16, 36, and I forgot 25, etc. That's how we simplify a few surds. peterblakemaths.com. Catch you next time.